Hi, this is Dolphy Fernandez. I will be presenting to you Big Data case study for analysis of application logs for the Big Data Analytics course at Harvard University. The first question is, why do we care about logs? For any application that is running live, which has real-time users, we have a massive amount of flowing information in the logs that would like to be captured, and especially because logs critical information such as user behavior, trends, operational data, and even data that could help us prevent from getting hacked. So how can we do that? First of all, automating parsing and analysis, since manual sifting through the logs could be really painful, if not impossible. Logs can come from a variety of sources. Variation in structure from several sources, which could have multi-dimensional format, is very difficult to understand. We have to make our log capable of informing us if there are any exceptions or random behavior. Moreover, it'll be nice to have some visibility and insights to the application without having to read the logs. And above all, if we could have machine learning tools hooked up to the logs, we could learn interesting trends or predictions that we could use for a business or application performance. So the big question now is, how can we achieve all of the above that we mentioned? That too at a big data scale with high availability, with data replication, scalability, and cloud readiness. For this project, we will demonstrate how we can set up and use Elk Stack for log aggregation, analytics, and visualization. We'll use Docker technologies for deploying Elk Stack. We will demonstrate how we can push large logs into the Elk Stack and how Elk manages to read those information, categorize those, and present to us in a nice and readable format. Later, we will use Spark machine learning to predict the number of requests that comes from a particular region on a particular day for that web resource. The output of this machine learning could be funneled into a web proxy caching mechanism to reduce network latency by intelligently providing the resource beforehand. And by providing the right resource beforehand to region-based web proxy servers, we could reduce the server load and bandwidth usage. This could really improve the perceived application quality. This diagram shows you what we intend to do in application. First, we will take a huge log file, which is over 100,000 log entries, and push it to Elk Stack. We will configure Elk in such a way that it intelligently understands and presents output in a nice and a readable format. We will generate a couple of graphs to demonstrate how easy it is to learn from the logs and display the information. At a later stage, we will work on Spark machine learning tools that will consume the data from Elasticsearch Scroll API and generate some predictions. The project setup. As you can see in this diagram, we bake Elasticsearch, Logstash, and Kibana as separate Docker containers and use Docker Compose as the orchestration tool to build all of these Docker containers. Docker Compose does a great job at hooking them up together so they communicate well and is responsible for building and deploying the Elk Stack. We can use this build to be deployed across any systems. It could be Amazon Web Services, OpenStack, virtual machines, or even the local machine. Now let's deep dive into the Elk Stack. The Elk Stack comprises of three major components: Elasticsearch, Logstash, and Kibana. In the further slides, we'll talk about what all these components do individually and how they come together to solve the big problem about logs. Logstash. Logstash is an open source tool that is capable of consuming large amounts of data, apply filters, and is responsible for forwarding them to multiple outputs. In our case, the Elasticsearch. Logstash pipeline consists of three stages: the input stage, the filter stage, and the output stage. The input stage specifies how you intend to send data to Logstash. In fact, how Logstash is going to consume that data. We could consume data in Logstash via files, via TCP, and there are a lot many options that Logstash provides. The filter stage is the processing component which allows us to configure Logstash to filter data that has been read by Logstash and perform certain operations. We have a lot many plugins that we can use for filters, some of them being Grok, GeoIP, Drop, etc. We'll go into details later. The output stage. This is where the Logstash knows where to send the output. It could be an Elasticsearch, it could be a file system, or something else. This is a snippet from our project. This is how Logstash input pipeline looks like. First, we mentioned the TCP port that the Logstash is listening to. The second, we have the file plugin wherein we specify the path that the Logstash is supposed to read the data from. This again is a code snippet from our project. Logstash filter pipeline is extremely powerful and configurable. As you can see here, we use few plugins that allow us to modify the input and apply filters to them. For example, we use the date plugin to check the timestamp matches the correct format. We use the Grok plugin to match the message to the Apache log format. The next is the Logstash output pipeline. As you can see here, we use the Elasticsearch option to configure host and our index. You can think of index as a database. Secondly, we use the CSV option to send the data to a path. We also use the standard output to print out the filtered logs. Elasticsearch. Elasticsearch is a very powerful search and analytics engine that's built on top of Lucene. Elasticsearch makes it extremely easy to parse and search for massive amounts of log files. It also provides scalability and reliability of data. It provides DSL query, easy REST API, and a full text search. Elasticsearch is schema free, which is very important because since we get a lot of data from various sources, it's very easy for us to just dump the data in Elasticsearch and let Elasticsearch make sense out of it. Here we use the Sense Chrome plugin to query Elasticsearch. We spoke about GeoIP in the Logstash plugin section. As you can see here, GeoIP reads the client IP and looks up the location information and populates the GeoIP element here. Kibana. Kibana is an open source visualization and analytics platform that can be easily hooked up to Elasticsearch so that it can read and interact with data. With the help of Kibana, we can generate dashboards that are capable of displaying data in real time. Kibana is very rich in graphical widgets such as area chart, tag cloud, heat map, pie chart, etc. As you can see here on Kibana, on the left side, we have three major components that we'll talk about: the Discover, Visualize, and Dashboard. Here in the Discover tab, we see that we have data that is read from Elasticsearch. The Visualize tab allows us to customize and create several graphs that can be later hooked up to Dashboard. Kibana Dashboard is pretty customizable and can be arranged in the way you want. Now it's time for some demo. Running Elk is very easy. For the sake of demonstration, I'll start up a AWS instance to demonstrate a fresh install. I'm going to skip some steps from the instance creation from this demo in order to save time. Once I have my instance up and running, I'll go to my workspace and run the docker compose command to build my containers. The next thing I will do is run docker compose up command with a -d flag that will run the application in the background. This should bring up the entire Elk stack. And that's about it. What you can see here is the Kibana website. As you see, the index is properly set up, but you see no results found. The NASA logs are from August 1995, so we need to select that date. Now we select the date range we are interested in and wait for the results to load up. As you can see here, we have a nice graph wherein we can zoom in and drill down into details. This is the Kibana dashboard. Kibana has a lot of powerful widgets that allow us to create and generate reports with a lot of ease. Elk is a great tool, but it does have some cons. Elk is free, but it does not necessarily mean it's cheap in the long run. There are several tools out there, such as Sumo Logic, Graylog, Splunk, Logly, that could provide more features and more flexibility in searching. This brings us to the part 2 of our project. Now that we have read huge amounts of logs into our Elk stack, we will now consume this information from Elasticsearch into our Apache Spark machine learning. This is how Spark is going to consume data from the Elk stack using Elasticsearch Scroll API. The data will be fed to the decision tree so that we can predict the request hits coming from a particular region on a given day. Here is the algorithm for Spark machine learning. So at step 1, we use the scan and scroll API from Elasticsearch to consume data. Scan and scroll algorithm allows us to keep pulling batches of results from Elasticsearch. This is very important since we cannot use the search API to query such large amounts of data. Now I'm going to run my Spark machine learning scripts that is going to read data from Elasticsearch in batches and will predict the number of request hits per region per day. We will see the results later in the slides. Next, we speak about Apache Spark's machine learning implementation of decision tree for regression. Here, we create a Spark context object, create an RLD, extract the features and labels, and then basically train the data. Once we have trained the data, we predict the model and then plot predicted versus actual graph. And that's all I have for the presentation. In conclusion, I would like to say that Elk and Spark ML are great tools for big data analytics and machine learning. You could use this in combination to do a lot of analysis on your logs, especially monitoring performance, viewing operational data, and learning from your logs. Something you need to keep in mind is that there is no one size fits all solution. There are a lot of technologies out there which might better suit your need and the in-house technical expertise. Thank you so much for listening to my presentation.